Good evening, everyone. My name is Karthik. I am studying in CSC, VVIT College. Today, let us discuss about readers and writers' problems in synchronization. So, exactly what is this problem? Is actually we know that a specific region is shared between among several processes. Some process want to read the data, and some process want to update the data. Where which means update includes reading and writing. So some process will just want to read the data, whereas some process want to write the data also. So in this for this we are trying to classify that the processes which are trying to read the data are called readers, whereas the process which try to update the data are called writers. So there will be no problem if two or more readers access the critical section or the shared data directly, which means for take an example, if someone if there is something on a board and many students are copying it, like there are many readers who are taking the data from the board. So many readers accessing the critical section is not at all a problem. But whereas if a writer is if a writer is writing the data, and also another writer is also started writing the data, then there will be a chaos that what data should be taken, either the first writer or the second writer, or else if one is the writer and and other one is reader, so there is again a chaos that a writer is writing the data, but the reader is reading the data which is not updated, or maybe the vice versa. So this will give many chaos. The data shared will be incorrect between the reader and writer. So for this, we are giving the exclusive access to the writers, such that when writer takes the critical section, no other reader or writer can access that critical section, so that we can actually take solve this problem. So this synchronization problem is called readers and writers problem. So move on to the next slide. So how to solve this problem? So for solving this problem, we are taking two semaphores and an integer variable. So the first semaphore is mutex. We all know what mutex is. It is used to ensure the mutex exclusion. So we also had a read count variable. We will see what the read count variable is. So mutex will ensure the mutual exclusion when readers and uh, which keeps the track of the read count variable, and WRTB another semaphore, like it is a write semaphore. It is shared among both the reader and writer, so it is the common data between the both readers and writers. So and the third one is read count variable. It is not a semaphore, it is just a variable, but it keeps the tracks of number of processes that are currently reading the projects. So read count, as its name specifies, number of processes are currently reading the process. So how to do this? So let us take this example, writer process. So as we can see here, we actually seen that mutex and write variable write semaphores are actually initialized to 1 first. So so here wait for suppose write process is started first. So in this do section, there is wait of write, which means write is actually 1 first, and it will be decremented to 0, which means the write process is acquiring the critical section, so it will perform the write operation. So at the same time, consider a read process is also entering the data and entering into the process. So here wait of mutex is also 1, weight of mutex will makes that weight of mutex will make it 0. So we incremented the read count here. Let us see. Read count is actually at first it is 0 and read count will be 1. See here, if read count is equals to 1, we need to wait, which means weight of WRT, but we already got here 0, which is write is already updated since it is shared between both writers and readers. Read count equals weight of WRT will makes no change, which means the control will be stopped here since the writer is accessing the resource. So we cannot the reader cannot read the data until the writer process leaves the WRT variable. So we seen the if the starting is started with writer process, consider we started with reader process. So now actually the mutex is at first it is 1 and it is changed to 0 since weight of mutex will decrement the value. So weight of mutex will be 0. Since this actually means a reader process is entered into the it is trying to read the data, which means the read count value should be incremented because a reader process entered. So we will increment the read count data, consider it as RC. So RC will become 1. So here read count is equals to 1. We written a condition which if read count equals to 1, weight of WRT. Weight of WRT means since a reader process is entered into the is trying to read the data, we should not write the data. So that's why we are writing weight of WRT, which makes WRT equals to 0. Remember, WRT is the common section between both readers and writer process. So the weight of WRT makes if any writer wants to write the data, then weight of WRT will be first it will evaluate the weight of WRT. Here we can see that WRT is 0. So weight of WRT will makes no change. So such that writer process cannot write the data. So here we succeeded in making when a reader process is trying to read the data, we succeeded in making writer process to stop writing the data. So up to here we completed that. See here, no writer enters even if one reader is present. So reader is present here, so the writer should not write the data. After this, we wrote signal of mutex, which means we already discussed that many readers can read the data, but if a writer is trying to write the data, no other reader process or no other writer process should access the critical section. So signal of mutex will make sure that a reader process is entered so that it allowing another reader process to read the data. So see here, other reader processes can enter while this current reader is inside the critical section. This reader process will enter into the critical section, which and enables other reader process to start reading it. So so after this, the current reader process will perform the critical section operations here. After this, the reader process should leave the critical section. For that, it need to decrease its count. See here, we need to decrease the count, but as we have already seen that Here mutex is related to read count. So as the read count is decreased, we also need to decrease the mutex first. So that's why we wrote a mutex wait operation here. So this will make sure that the process is getting out of the control, which means it further no need of the critical section. So we already had one process here, and the read count will become 0. So this will make it a 0. So after this we had a condition where read count is equals to 0. Is it true? Yes, it is true. So signal of WRT. Read count is equals to 0 means there is no reader process to read the data, which makes the writer process can start writing the data into the critical section. So we gave signal WRT here, which increases the WRT value to 1, So before we seen that WRT is 0 because weight of WRT is happened here. After this, we actually incremented the value of this, which makes it 1. So the writer process can write the data here, can write the data of the shared location. After this, since the reader process is leaving, it should signal the mutex saying that it is leaving the process. So this is the entire process running in the readers and writer process. We can simply see that firstly mutex is in wait. After that count is incremented. If the count is equals to 1, writing should be stopped. It should be stopped. So we need to wait. After this, we need to give a signal to the mutex so that other readers can enter while the current reader is executing its critical section. So after this, so if any other reader process is entering, then the read count will becomes 2, since already one already entered, and it signals the mutex to take another reader. So consider another reader process trying to access it. Weight of mutex will become 1. So the read count will be 2. Here the condition will not be again, it won't be evaluated, since read count is not equals to 1, it is equals to 2. It again signals the mutex to give access to another reader process to read the data. This will happen eventually many times. So while the current reader is performing the reading here, after this weight of mutex is written, which will makes we need to after the performance of critical section, we need to remove the process, remove the reader process. So read count should be less, decremented. So for decrementing, we also need to decrement the mutex value, since they both are related, or mutex is the semaphore which makes mutual exclusion when the read count is updated. So we need to decrease it. If the count is 0, we need to let the writer to write the data. Even if the count is 1, we should not let writer to write the data, so that there will be no ambiguity or no chaos for accessing the data. Finally, the reader will leaves by giving the signal to the mutex. So this is the readers and writer process. Thank you.